Hello, everybody. We're going to work through some environmental issues associated with agriculture. We're going to do this in a part one format, and we'll do another video that talks about some other issues as well. So we'll do these video notes. We've got a short reading we'll work on in Canvas and sort of an activity and discussion board in the Canvas module as well. Our objective today, we want to be able to explain different types of environmental issues related to farming, as well as potential solutions. We'll talk about issues of soil degradation, desertification, deforestation, and working with our water resources. We'll also be talking broadly about the idea of sustainability. So, yes, we need to farm. Yes, we need food for a growing human population, but we know some farm practices are more sustainable than others. In other words, sometimes we could carry on those farm practices for long periods of time. Other farm practices, while they may be efficient and produce lots of food, may have environmental impacts that mean that they can only be carried on for a finite amount of time. And then we'll run out of a resource like water, or we'll mess up the soil to the extent that we can't farm, something along those lines. So let's start off with our soil. Soil is something we don't often think about. Just call it dirt. But turns out soil is actually a big living organism. So soil quality is really, really important for farming. It's got all kinds of microbes and fungi that are essential for good plant life. Has all the nutrients that are in our food, right? They get taken up through plant roots. And without all that stuff, then you have poor quality soil, you have lower farm yields, you have less food. So one thing we'll talk about, soil that's compacted. So in this diagram here on the left-hand side, we can see all these nice gaps between soil particles. On the right side, that's been compacted, so those gaps no longer exist. So the downside of that is less air and less water can move effectively through soil. You don't have air and water, you don't have that nice healthy microbial environment, you don't have the natural fungus, and plant roots really have a hard time breaking through as they grow. So you're going to have negative impacts on your plant growth and negative impacts on your farm yields. You can see this other diagram with those actual roots drawn in on the left. Better soil structure, again, looser particles, easy for that plant root system to drive through and be healthy. On the right, we see the opposite, a smaller plant in this case in the drawing. Here's a quick picture of what good, healthy soil in the Midwest of the United States looks like. You can see the scale, the human for scale here. This is not a farm crop. It's not corn or soybean, but it's natural prairie grass from the Midwest. But you can see that root system is large and long, and that soil is really nice and healthy. So that's what we want in a farm. But we know that modern farm practices can create this compacted soil, primarily because we use such large, heavy machinery. Now, that's useful because it helps us plant and harvest large fields, which is efficient, get high yields, lots of food. But if we don't manage that machinery properly, then we're going to the result is going to be this compacted soil. So stuff like, buying GPS systems, so you're not rolling over the exact same rows each year with your heavy tractors, heavy combines, can help farmers mitigate soil compaction. Some other issues in soil degradation, we can also lose soil. So we can lose it through erosion. So wind can blow away topsoil, water can carry it away. And soil, while also being a living thing, is a finite resource. In your lifetime, we could not rebuild, a foot of soil in most places. So if it gets lost to erosion, then it's gone for quite a while. There's several things farming can do that makes soil more at risk for this type of erosion. There's also several things that agriculture can do to mitigate that risk. So one of the things is tillage, when a farmer plows their fields. So on the left, we can see what's called conventional tillage. Whatever you've got left in the field, maybe you had corn and you have leftover corn stalks, you're going to take a plow, you're going to move through that field, you're going to sort of turn all that over, and you have all this exposed soil. So while that may be effective for breaking up existing soil, it leaves what's there at risk for wind and water erosion. So in the center and the right, we have two other methods, conservation tillage and what's called no-till. So you have the leftover crop from the previous year, and you simply plant over that. That, again, mitigates this risk of soil erosion and helps that soil be healthier. Another thing farmers can do, cover cropping. So in the wintertime, after the harvest season, maybe you planted corn as your primary cash crop, you can put in, say, peas or alfalfa or some kind of other field crop. This does two things, right? A, it covers the ground in a physical sense, leaving that farm field protected from erosion. B, some of those crops actually put in nutrients like nitrogen into the soil, where planting corn will take that out, right? So you have this give and take. Cover cropping can be really useful. Crop rotation is also really important. This has been a long-standing practice of farmers, but it's something that we want to keep seeing conducted out there in the fields. So maybe as an example, if you have 3 fields, year one has corn, the second has oats, and the third is fallow, meaning we're not planting it. We're literally just letting it rest, letting it sleep, basically. And then you'll rotate those. So the corn field would have oats, the oat field would be fallow, and so forth. So these are ways that farmers out practicing agriculture can reduce those effects of soil degradation. Last thing we'll talk about with soil is salinization. Essentially the buildup of salts, right? We think about table salt. There's other salts out there, but salinization is the buildup of salts in our agricultural soils. This is, of course, bad because if there's too much salt, plants won't be able to grow properly. So here's a quick picture of what accumulated salt in Colorado looks like. There's a variety of reasons that this can happen. Some of it is over or improper irrigation. So here's 2 quick pictures. On the left, we've been using some drip irrigation. We have cotton being grown in this case. The left still looks good after 5 years, but you can see after 15 years, that white crust on the soil, we've got salinization of that soil. We've got these accumulated salts, and that's going to have a negative impact. You can see fewer cotton plants literally on that field. So there's a big negative impact here. Farmers on the coast, say back home in my home state of South Carolina, are also facing salinization because of simply rising sea levels. But nonetheless, soil salinization is something we want to look out for and mitigate. We can look back historically to the Dust Bowl in the 1920s and 30s, a big agricultural disaster for American farmers, partially caused by poor soil management. So that was devastating for the American farm community in parts of the Great Plains, and partly a man-made disaster. Let's talk about desertification. We're kind of transitioning here from the soil to some other issues. We know that certain production systems happen in semi-arid areas, right, on the border between a desert, right, and on the other side, places that receive more rainfall. Oftentimes, these places see production systems like pastoral nomadism in periphery countries or cattle ranching in core countries. However, if we overgraze land in a semi-arid area, bottom line, that grass is going to disappear because it's all been eaten, and we'll have the desert take over. So overgrazing of animals is the primary cause. So let's take a second and pause here and take a look at this map. We've got 2 tasks: identify some regions at highest risk for desertification, and think about 2 production systems that might take place there. So if we see here the American West, right, major risk, very high degree of hazard along the Sahara Desert, where pastoral nomadism might take place. In contrast, cattle ranching out in the American West. We've got Australia, Central Asia. These are the semi-arid places at risk for desertification. Okay, moving on to deforestation. Basically, agriculture creates this land use conflict. So if we have a forest and we want to farm, well, we need to clear that forest. If we're out in the American Midwest, we have this conflict between natural prairie or grassland and agriculture. And if we're, say, somewhere in a coastal environment like southern Florida, we have tension between existing wetlands and agriculture. So what we know is that across much of the earth, we've deforested, right? We've cleared forest, we've converted prairie into cornfields, we've converted wetlands into all kinds of agriculture. Today, the Brazilian Amazon is kind of the key feature. Let's take a look at a couple of quick examples. So this is a little 30-second clip from YouTube, Google Earth, taking a look at deforestation over time in the state of Rondônia in Brazil. So composite image from satellite in 1975. Fast forward to 1989, you have the creation of some roads and the increased clearing of land. By 2001, that's simply compounded. And by 2009, we see a tremendous amount of this land clearing. So why is this happening? Let's take a look at our next slide here. Why is Amazon rainforest disappearing? Well, 3 reasons. A, that timber is very valuable, and we need timber to build all kinds of stuff with. B, once we clear that land, we can run cattle on it. Brazil is a major cattle producer, both for the domestic market and for exporting. And then lastly, those fields we can also convert into grain farming, particularly corn and soybeans. Those are mostly being used to feed cattle and pigs, both in Brazil, in the United States, and especially much of this is exported to China, where there is a growing demand for meat like beef and pork, and so China needs much more of this grain to be imported for that demand. All right, moving on to water issues. This set of notes will deal with some water issues. We're going to take a second set of water issues and a different set of notes. But let's talk about aquifers. So we have surface water and we have groundwater. We'll talk about surface water in a minute, but that's, of course, all of our lakes, streams, and rivers. Groundwater is a little bit different. So we have a little diagram showing us kind of what groundwater looks like. It's not necessarily an underground lake, but usually it's loose soil, loose rock, porous, that can contain water. We can drill wells and pump that out. So groundwater in many places, particularly arid environments, is a very important source of water for agriculture, for cities, for really all users. Let's take a look at the Ogallala aquifer out in the American West as a specific case study. So we can see here it extends north-south, Nebraska, Kansas, Oklahoma, Texas. We're really going to focus on why do we care about it. And this map begins to show us that. We see these big declines in water level change in the aquifer, some minor, but some very, very major. So why is it happening there and why do we care? Let's put together the map of the aquifer with some maps of certain production systems. So in the USDA map over here on the right, let's take a look at southwestern Kansas. We can see Haskell County marked out on the aquifer map here. If we transition to the cattle and calves map we have up, we can see that section of Kansas has a significant number of cattle and calves in its agricultural industry. So 1 dot on this map equals 10,000 cattle and calves. We can see a tremendous intensive use of the land through that. And of course, that's going to demand water usage. Kansas, particularly the southwest corner, very arid, or semi-arid rather, and so groundwater pumping is the primary source for water. We've also got irrigated crops. Let's take a look at wheat here. Again, the same stretch of southwest Kansas and the panhandles of Oklahoma and Texas. Major areas for irrigated wheat. We can do wheat in other areas, simply dryland farming, relying on rainfall, that type of thing. But in the areas on the map shown here, irrigation is the ticket. You've got to pump water out of the ground or you cannot farm wheat. So we can see a second land use, a second ag production system there. We can also see third. Mom is concerned about our earthquake. Okay. So in the bottom corner of Kansas here, um, we've got again lots of irrigated corn, thousands and thousands of acres. So what does that look like in the landscape? Looks like this: our typical brown color of this arid environment, coupled with the green of center pivot irrigation of pumping groundwater out of the Ogallala aquifer. So this is a case study of overuse, and this area in the very near future is going to have to really change its methods in order to continue working in agriculture. Let's do a little bit of chart reading real quick. We know that's an important skill for the AP test. Which states have seen the greatest decreases in water storage? Remember, when we can quantify, we want to do so. And so you got to know your state abbreviations here, but you can see Kansas, big decrease in recoverable water, more than 50 million acre feet. And Texas looks like the other big loser here, well over 150 million acre feet loss in recoverable water. So again, simply be able to read the chart, state what it's telling us. Very important skill for the AP test. All right, draining wetlands, big topic. We've got a case study we'll take a look at with the Everglades here to wrap this up. So the Everglades, a large wetland area in South Florida. You can see the township and range system in this old 1947 map being applied over this area. And the whole goal was to divide it up and drain the wetlands, the Everglades, and provide land for agriculture. So what it used to look like, we've got pre-development here, basically pre-World War II. We've got sawgrass marsh. We've got some deep water areas. We have what's called wet prairie. We have areas of forest, marshes, swamp forests. We have a whole range of ecosystems that existed. And essentially, from Lake Okeechobee down to Miami or down to the tip of Florida, you used to be able to basically paddle a canoe, right? It was a river of grass, literally. However, starting in the 1900s and especially afterwards, you can see on this map, we had canals being built, and they were draining water out of Okeechobee. We were draining water out of those natural marsh and swamp ecosystems. We wanted to make that land usable. We wanted to convert it into agriculture. You can see a much more formalized picture of this. So the area here in the sort of the light gray, that's all developed agricultural land. There is some of the natural Everglades left, but it's been reduced by at least 50% in size. And here's what it looks like on satellite. So those agricultural areas, we can see that classic grid system of the township and range survey system. And so this is all kinds of stuff. This is sugarcane, this is green beans, this is tomatoes, this is lettuce, basically vegetables that feeds the East Coast throughout the year, not only in the summertime, but also in the winter. In addition to draining something like a wetland, we've also got surface water depletion. That's a big deal. And so we're going to take a look at a case study and then circle back home to the Great Salt Lake Basin. But what we know is that agriculture can account for 80 to 90% of water usage in the American West. Agriculture, of course, uses water. So does industry. So do cities, right? People need water. But agriculture is a major user. In the American West, we know it's pretty arid, and so our rivers and reservoirs that are made from damming those rivers are essential for farming, for city development out here in the American West. So let's take a look at a case study. We're going to go to Central Asia first. The Aral Sea, over time, has dried up, right? So this imagery starts in the mid-'80s and goes to 2016. The basic reason that this has happened, and you can see it if we replay the video, in the upper right corner, these are all fields created for irrigated cotton. Cotton's a major cash crop. It became a major cash crop for the country of Kazakhstan. So after they They started diverting water from the main rivers the two main rivers that fed the Aral Sea. They put it on their cotton fields. They developed an excellent cotton industry, but at the cost of drying up the Aral Sea. So why do we care about that? Well, first of all, people who live there now face these giant dust storms from the big dry lake bed, right? So you dry up a lake, you have lots of loose soil, and you get massive dust storms. We also had a giant fishing industry on the Aral Sea. That's now completely gone. Citizens who still live there face major water scarcity. And we also have the natural world that's been impacted. So the ecosystems, whether it was for waterfowl, for fish, regardless, that ecosystem is gone. So, are there lessons here for Utah and the Great Salt Lake? Let's take a look at some more satellite time lapse. This is from 1984 again to about 2016. And what we can notice is that over time, of course, the Great Salt Lake has been shrinking. So, a professor from Utah State has done some research. This was published in 2016. Basically, they found that agriculture accounts for around 2/3 of the Salt Lake Basin's water use. They found that as a result, we've seen the shoreline be reduced because of this increased water usage. So the white line here on their map, sort of the historical elevation of the lake and its water volume, and you can see what it was looking like in 2016. Now, the good news is we've become more efficient at using water. So they found that per capita, right, per person, municipal water use in cities has actually gone down 18% in recent years. However, because of the rapid growth that's been happening on the Wasatch Front, our overall municipal water use is actually increased by 5%. So the bottom line is the Great Salt Lake continues to shrink. The impacts, just like the Aral Sea, we've seen large dust storms. We saw one of these particularly in 2015. And we also have industries like shrimp, waterfowl hunting together. It's a $150 million industry. And so we're looking at economic losses as well. So to finish up, you need to be able to summarize some of these environmental issues, right? We need food, of course, but we know that farming has some downsides as well. Head over to Canvas and take a look at the module. There'll be a discussion board and a short writing activity. Also note, this actual PowerPoint is attached in the module as well. Thanks for listening.